Hey guys, today we're going to look at some new theorems and we're going to be drawing some pictures, so make sure you have a straight edge with you. To kind of review definitions here, rules that are accepted without proof. We should know those to be postulates. Another name you could use here though is axioms. So rules that are accepted without proof are postulates or axioms. Rules that need to be proven are theorems. Okay, so one thing I want you to know, these are all point, line, and plane postulates. And I don't care about this postulate number. They're numbered this way because that's how they're numbered in the book, but you need to know what these postulates say. Don't write down on your homework that the answer is postulate 6. You need to write down exactly what that statement for postulate 6 says. So, through any 2 points, there exists exactly one line. Hopefully that is coming back to you from our very first lesson. Through any 2 points, there exists exactly one line. If I want to write this out kind of in pictures, I would say if I have 2 points, so if 2 points, then through those 2 points there is a line. Use your straight edge there to make that nicer. So if 2 points, then 2 points on a line is how you would write that out kind of in pictures. All right, the next one says a line contains at least 2 points. So this time the line comes first. So we're going to say if line, then we have our line with 2 points. Our next postulate, if 2 lines intersect, their intersection is exactly 1 point. So we draw this out. If we have our intersecting lines there, then basically you're just going to kind of highlight these 2 points intersection, or this point intersection of these 2 lines. Through any 3 non-collinear points, there exists exactly 1 plane. So if I draw this, the first thing I see is 3 non-collinear points. So if I have 3 points, then I have a plane with 3 points inside it. All right, a few more. We're not going to draw all of these. You are welcome to draw them if you would like. A plane contains at least 3 non-collinear points. So if you were to draw this one, I would put if, then just an empty plane, that parallelogram shape, then that plane with those 3 points inside. If 2 points lie in a plane, then the line containing them also lies in the plane. So what I see is if 2 points in a plane, so you draw your plane, put 2 points inside, then you would draw your plane with your 2 points with a line going through it. All right, our last postulate is if 2 planes intersect, then their intersection is a line. And we've drawn this before. So I'm going to show you again. I would draw a straight on box here to represent one of the planes. And then I'm going to dash the box behind. So it's kind of like two walls, or it kind of looks like a door opening. Looks like this. Then I'm going to draw it again. There's my dashes. And I'm going to highlight this line. Put arrows on it. That's where it's intersecting. We can go over that together in class if we need to. Go over that drawing. So now example 1 says, state the postulate illustrated by the diagram. And you are going for word here. So it looks like if 3 points, then points inside a plane. So if you go back, flip back to the page before, that one looks like through any 3 non-collinear points there exists exactly one plane. Okay, so we've talked about this a little bit before, but we're going to talk about assumptions that you can and cannot make based on a picture. So looking at this diagram, things that we can assume. We can assume that all of these points are coplanar. Looks like they're all sitting inside that plane. We can assume that AHB and AHF are a linear pair. Angle AHF. There's other ones that could be a linear pair. You could have said BHJ or BHD could be a linear pair with AHB. We can assume that AHF, so this angle right here, and JHB, so angle JHB, are vertical angles. They're touching at the vertex. We can also assume that A, H, J, and D are collinear. They all lie on that same line. We can also assume that AD and BF intersect at point H. And remember, you can write out the words point H, or just that capital letter H represents point H. Things we cannot assume. G, F, and E are collinear. It looks like they might line up, but we can't assume that. We don't know that. The next two kind of go together. We can't assume that B, F, and CE are going to intersect. We also can't assume that they're not going to intersect. We just don't know what's happening outside of this picture. We also don't know that BHA and CJA are congruent to each other. Last one, BF and CE are perpendicular. We don't know that. It looks like they're probably not, but we can't assume that. We also can't assume that angle AHB is a 90-degree angle. Okay, a key thing that you need to know definition is a line is a line perpendicular to a plane if and only if that line intersects the plane at a point and it's perpendicular to every line in the plane that intersects at that point. So read that definition a few times. A line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. We'll talk about that in class as well. All right, which of the following statements cannot be assumed from the diagram? So E, D, and C are collinear. It looks to me like these 3 points are all sitting on the same line. They're collinear. We can assume that. The intersection of BD and EC is point D. So BD is right here. EC is right here. Looks like they intersect at point D. BD is perpendicular to EC. There's nothing here telling me that line BD and line EC are perpendicular to each other. So we can't assume that one. Then EC is perpendicular to plane G. Well, plane G is this one right here. So, and that's that definition we just talked about. Unless we see that it's perpendicular to every line sitting inside that plane that meets at point D, we can't assume that either. So our last 2 statements are not statements that we can assume. Alright guys, that's all I got for today. So I will see you in class. As always, come see me if you have any questions.